the graphs of sine and cosine. In this video we are going to continue with sine, cosine, so I'm also going to add cosecant as well as, let me say, secant as well as cosecant. These also graphs, you need to know them. So let's just do a recap on how the graph of sine looks like. So let's say you have the xy plane. You and I, we know to say that the maximum amplitude of sine is +1 and the minimum is -1. So let's say we have 0 and this is 90, so it's going to be 180, 270 and 360. So the first point has to start from 0. That is what we said for sine, and that one has to be sine, which is equal to positive sine x. We also discussed on how the graph of y being equal to negative sine x looks like, as well as the graph for cosine, both positive and negative, we discussed. So from there we are going to continue. So the next point is going to be somewhere here, 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 and the last one is going to be somewhere here. So drawing a graph, it is going to look something like this. So this one is for the positive one, positive sine x. Then for the negative one, you just need to deflect on the opposite side. So the opposite side of the way the graph is moving is this side. So from here to here, here, then somewhere here, and the last point is going to be here. So the graph is going to look something like this. And this one is going to be y, which is going to be equal to negative sine x. So this is how you're supposed to draw, isn't it? We looked at these. Now, you and I will know to say that the opposite of sine is cosecant, and cosecant x is equal to 1 over sine, isn't it? So meaning to say, once you draw the graph of sine, the inverse is going to be cosecant. So let's try to look at how the graph of cosecant looks like. And that one is very, very important to know. So let's say we have a graph. Here we have +1, -1, 0, 90, 180, 270, and then the last one we have 360. Points, we have first one, the second one, third one, the fourth one, and the fifth one. Joining this, I'm going to have something like this. Okay. So this is the graph of positive sine, isn't it? This is how it should look like. Now, what about the graph of this cosecant? How is it supposed to look like? So it is very, very important to know that if you're graphing cosecant and secant, the first thing to consider is to consider the points in the x-axis. See, so this one is the x-axis and this is the y-axis, where the curve is cutting. So it is cutting at this point here as well as at this point, and the last point is this one. So that is where now you're going to draw what we call the asymptote lines. So I'm going to start with the first one, which is this one. So if I draw the asymptote line on this y-axis, this is what I'm going to have. What about at this point here? When I draw the asymptote, this is what I'm going to have, and lastly I'm going to have this one here. Right, so after doing that, you know to say that cosecant is the inverse of sine. So if the graph of sine is deflecting downward, if this is the graph of sine, where is the graph of cosecant going to deflect? It is going to deflect upward. So that is one thing that you need to know. So y is going to be equal to cosecant. So it is going to deflect upward. So as you can see here, this graph here, it is deflecting downward. So meaning to say, the graph for cosecant, it is going to deflect now upward. So it should not touch the asymptote lines, but they are going to meet at this point here and deflect like this. Here, the graph is deflecting upward. So meaning for cosecant, it is going to deflect downward like this. So therefore, this is the graph of y being equal to positive cosecant. So let me tell you this. For you to draw the graph of cosecant, the first thing you need to draw the graph of sine. And for you to draw the graph of secant, you need to draw the graph of cosine. That is very, very important to know. So let's try to look at also how to graph the graph of secant. So y is equal to secant, which is positive. So you and I, we know to say that the graph of cos looks something like this. If we have 0 here, positive 1, and then negative 1. So for cos, it starts from, for cos, if you have y being equal to positive cos x, it should start from the amplitude, maximum amplitude from here. So let's say 90, 180, 270, then 360. So the first dot should be somewhere here, the second one somewhere here, the third one here, the fourth one here, the fifth one has to be somewhere here. So the graph of cosine is looking something like this, isn't it? This is y equal to positive cos x. What about secant? Since we know that secant x is equal to 1 over cos, so it's more like the inverse, isn't it? So like I said, you need to focus on the points where the curve is cutting the x-axis. So we have the first point here and then second point. So that is where we're going to draw the asymptote line. And also this point here. So from here we know to say that it is starting from here, so it is deflecting downward. So for secant, it's going to deflect upward like this. Here it is deflecting upward for cos. For secant, it's going to deflect downward like this. Then lastly here, it is deflecting like this. It is deflecting downward. So for secant, it is going to deflect upward like this. So this is how you're supposed to draw this one. So this one is going to be y, which is going to equal to positive secant x. So this is how you're supposed to draw these graphs. So even for secant, for you to graph secant, the first thing you need to graph cosine, then you deflect cosine for you to have secant. So that is very important. So that is very important to know. So let's try to look at some examples. Now, let's say you have been given y equal to half sine open bracket x minus pi divided by 4 close, then minus 2. You have been told to sketch the graph. How can you go about this one? Sketching the graph is just very simple, but all what you need to know is the standard or the format. So y is equal to a, and here you can have any trigonometric ratio. You can have sine, then open bracket, and actually here you're supposed to have b, then x plus c, then close bracket. Do this, then close bracket. Then here you're going to have plus c, d. So that is very, very important to know. Alright. So for you to graph this one here, what are you supposed to find? The first thing, you need to find the amplitude, and the amplitude you find it as a being equal to modulus of a. So the value of a is the coefficient in front of the trigonometric ratio that you have. So in this case here, the amplitude is going to be this one. The amplitude is the maximum displacement of the wave, isn't it? So we have half. So half is going to be equal to modulus, then a is going to be equal to half. The use of the modulus is to eliminate a negative. Let's say, for example, if this one here was carrying a negative, what is going to be the amplitude? Let's say we had something like this. Similarly here, you're going to have a positive amplitude, because the modulus they help to eliminate a negative. So that is very, very important to know. So this is how you're supposed to find the amplitude. Alright, what is the second thing? Period. How do you find period? Period is equal to 2 pi divided by b, which is the value of b. So in this case, this formula for period only works for these 4 trigonometric ratios: cosecant, secant, sine, as well as cos. When it comes to tan, it's a different formula. So that is one thing that you need to keep in mind. So the value of b, you get it here or somewhere here, just depend on where it is. So as you can see, the value of b here that we have is just 1. But there are some questions whereby you can have y, which is equal to 2, then sine x, open bracket, 3x minus pi divided by 4, then close, let's say plus 1. So meaning to say the value of b here, it is 3. That is one thing that you need to know. So finding the period is 2 pi. We are following this one, so the value of b here is 1. So meaning to say the answer is going to be 2 pi. So this is what we have found. Now, there are also other things that you need to know. You remember the format? This one. So this one has to be just supposed to have b, then x plus c, then plus d. This one is representing the amplitude. This one is representing the value of b when you find in period. And let's come to this one. This one is going to represent the phase shift. We have what we call the phase shift. So what does the phase shift tells you? The phase shift tells us where the curve is going to start from. You and I, we know to say that when we are graphing sine, we need to start from 0 and go like this, isn't it? But if the question is having the phase shift is going to tell you where the graph is going to start from rather than 0 when you're dealing with sine. So how do you find the phase shift? You just get the same thing that we have here, and then you equate it to 0. So you say x minus pi divided by 4, and then you equate it to 0, and then you find the value of x. So this one is going to give us pi divided by 4, which is equal to 45 degrees, isn't it, in terms of degrees? So meaning to say this is where the curve is starting from, but the period tells us where the graph is ending, isn't it? So if we consider 2 pi, meaning we're going to start from 0, then draw a graph and end up to 2 pi. But since we have the phase shift, meaning we are starting from pi divided by 4 and end at 2 pi, this one doesn't make sense. Why? This is because you can only end at 2 pi when you're starting from 0. Have you gotten that one? You can only end at 2 pi when you're starting from 0. Now we are starting from 45. So where are we going to end if we are starting from 45 rather than starting from 0? So for us to know where we are ending, we need to add period plus the phase shift to know where we are ending in terms of the length in the x-axis. So we are going to add 2 pi plus pi divided by 4, and this is going to give us 9 pi divided by 4. I think you have gotten that one. So always, if the question is having the phase shift, for you to know where you are ending, you need to add the phase shift plus the period to know where you are ending. So as we are ending at 9 pi divided by 4 and starting from pi divided by 4, which is 45. So we are ending somewhere here. So that is very, very important to analyze. Then apart from the phase shift, we have what we call this D here. This D represents the vertical shift. The vertical shift. So the vertical shift is also very important. But one thing that you need to know here is that for the vertical shift, you're not supposed to solve anything. Rather, you just need to take the way it is. For the vertical shift is the value of y. So here we have negative 2. We just need to write it the way it is as y being equal to negative 1. If here we had positive 2, just need to say positive 2. But what does this tells us? This tells us where the graph is ending in the y-axis. We know to say that the amplitude that we have here is this one here, isn't it? We have this one here. And we know to say that we can have positive 1/2 or 1/2. We can also have 1 over or negative 1/2 in terms of negative y-axis. This is positive y-axis and this is negative y-axis. So for us to know where we are ending, we need to add plus this one here, which is the vertical shift. So the first thing I'm going to start with this one here in the positive y-axis. I'm going to add it to the vertical shift. So if I add, remember this one is negative 2. What am I going to have? This one multiplied by that, I'm going to get negative 4. Negative 4, we can say 1 minus 4, that is negative 3 divided by 2. This is what I'm having in the positive y-axis, meaning that is where I'm going to end, right? But what about this one? If I add also, plus, open bracket, negative 2. This one, which is positive 2 multiplied by that, that is negative 4. Minus 1, minus 4, that is negative 5 over 2. So meaning in the y-axis, which is the negative y-axis, I'm going to end at negative what? 5 divided by 2. So if I divide this one here, what am I going to get? I'm going to get negative 1, then 0.5. Then for this one here, I'm going to get negative 2. Let's say 5, yeah, negative 2.5. So let's just guess that negative 1.5 is somewhere here, negative 1.5 is somewhere here, and negative 2.5 is also somewhere here. This is what we have, but this is the vertical shift, isn't it? So the vertical shift, negative 2, is somewhere here, so you need also to indicate it. It's very, very important to indicate that one. And that one, you're supposed to indicate it in a dotted line like this. That one shows where the graph is starting from, right? So we need to say that we're supposed to start from where? We're supposed to start from the phase shift, which is this one here. And again, we know that we're supposed to start in the vertical shift. So where the phase shift and the vertical shift are meeting, that is where I'm going to start from. Okay? So you can just imagine that the vertical shift, let me say the phase shift is this one and the vertical shift is this one. So they're going to meet at this point here. So that is where now I'm going to start from. But one thing that need to make sure that is that this is my maximum amplitude and this is my minimum amplitude. So I'm not supposed to exceed this line here, although it's invisible, but I'm not supposed to exceed whereby I draw something like this. I need to make sure that when I draw a curve, it has to just reach at this point and then go down like that. So that is one thing that you need to understand here. So if this one is the first point, second point is going to be somewhere here, third one here, the fourth one is going to be somewhere here. So let me just put now these points so that you know what I'm talking about. So from here, we are going to move up to this point here. Then from this point here, we are going to move, this one is corresponding to this point here. Then from here, it is going to correspond to negative 2.5. This line here is corresponding to this one here. So we're supposed to, this one here is the minimum, isn't it? So it is corresponding to this point here. And the last point here, we need to end in the same vertical shift. So it has to be somewhere here. So let me draw the graph. So I'm starting from here and my graph is going to look something like this. So I need to go down, passing through this point and reach at this point here and go up like this. So meaning to say this one is going to be now my graph. So y is going to be equal to half, then sine, open bracket, x minus pi divided by 4. Then we can say minus 2. So this is how you're supposed to graph this one. Now let's say, for example, if you're graphing secant here, or let me just say cosecant, since cosecant is the opposite of sine, what are you supposed to have? What are you supposed to have? So let me just do this. If you're graphing secant, y is equal to 1 over 2, then cosecant, let's say open bracket, and this one was supposed to be what? It was having x minus pi divided by 4, then minus 2. You're graphing this one. The first thing you need to graph it like this as sine. Then the second one, you're going to treat this one here as the x-axis, since they are parallel to each other. So what are you going to do? You draw the line of asymptote cutting, where this curve is cutting the vertical shift, and also the x-axis, which is corresponding. So it's going to look something like this. So even here we have But one thing that you need to know is that we have the maximum displacement and also the minimum displacement. So that is where we're supposed to end. Okay, so this one also. So for the first part, it is going to deflect like this. Even this one here is going to deflect like this. Even here, upward like that. From here, you deflect downward like that. And like that. So meaning to say, this one is going to be y being equal to what we have here. So this is how you're supposed to graph this one. So let's also try to look at another. Now let's say, for example, if you want to graph this one here, y is equal to positive sine x plus 1. How can you go about it? What things do we have? Amplitude. R is going to give us 1. What else? Period. 2 pi divided by the value of b here is 1. So therefore the period is going to be 2 pi, which is 360. We don't have the phase shift here, but we have the vertical shift. So the vertical shift, which is y is equal to positive 1. But you and I will know to say that to know where the graph is going to end in terms of the deflection, we need to add the vertical shift plus the amplitude. Now amplitude can be negative 1 or positive 1 in terms of deflection upward and deflection downward. So let's start with the maximum deflection. It's 1 plus 1, which is going to give us 2. So meaning it's going to deflect upward up to 2 units. Then downward, negative 1 plus 1, which is giving us 0. So meaning in terms of deflection downward, it is going to deflect 0 units. So that is actually in the x-axis. So drawing the graph on the xy plane, this is what we are going to have. 0, pi divided by 2, pi, 3 pi divided by 2, then we have 2 pi. This is what we have. So maximum deflection, that is positive 2. But what about the vertical shift? The vertical shift here is positive 1. So I'm going to draw a dotted line. The vertical shift is telling us where the graph is going to start from. So the vertical shift and the phase shift tells you where the graph is starting from. In short, in terms of the coordinate, it is the phase shift. Okay, it is phase shift comma what? Comma vertical shift. So that is one thing that you need to know in terms of the coordinate. Phase shift represent x, vertical shift represent y. So that is very important to understand and to remember. So in terms of the maximum deflection, it has to end on positive 2. In terms of the minimum deflection, it has to end on 0, which is actually in the x-axis, as you can see. So let's start. The first point, since we are starting from the vertical shift, which is positive 1, the next point is going to be 90, 2, which is going to be somewhere here. And the second point is going to be 180, 0, which is this one here. Since in terms of the minimum deflection, we are ending at 0. So it is more like 180, 0. And in this case, the value of y is 0. This one here. So that's the reason why I'm having a dot here. Then the second one, it is this one here, which is 270, maybe we just do this, not that one. The second point from here, it is going to be somewhere here. Okay, so we have 180, 1, which is the vertical shift, so it has to be somewhere here. Right, then from there the next one is going to be this one here, which is going to be 270, 0, so it's going to be somewhere here. Then the last point is going to be 300, 1, which is going to be somewhere here. So in terms of drawing the graph, it's going to come out like this, then goes like that. So this one is going to be y, which is going to be equal to positive sine x plus 1. So this is how you're supposed to draw this graph. Let me give you another example. You have been told to graph this one. How can you go about it? So you know to say the amplitude is this one here. Vertical shift. So let's start with the vertical shift first for some reasons. So the vertical shift y is equal to -1. So we can find where now the graph is going to end. So we know to say the amplitude can be -2 and +2. So I'm going to add it with this one. So in terms of the maximum, y is going to be -1 plus 2, which is y is going to be equal to +1 in terms of the maximum. What about the minimum? Y is going to be equal to -1 minus 2. Y is going to be equal to -3. That is in terms of the minimum. But we know to say that the vertical shift is -1. So that is one thing that we need to know. But in terms of deflection, on the positive side of y, it is +1. In the negative side of y, it is -3. From there, we can find the period. So period is equal to 2 pi divided by value of p. The value of p here is 1. So period is going to be equal to 2 pi. So this is what we have, because here we don't have the phase shift. So we can work out this one. So we have x, and then here 0. This one here, it is pi divided by 2. This one is going to be, alright, pi. This one is going to be 3 pi divided by 2. Lastly, we have 2 pi. Right, so let's put the values. So here we have the maximum, which is +1, then the minimum, which is -3. But what about the vertical shift? The vertical shift is -1, so it is somewhere here. Let me just put it somewhere here. So we need to draw a dotted line like this, meaning to say that is where now the graph is going to start from. But you and I, you know to say that this is the positive sign, which is y is equal to positive sine x, isn't it? So it has to deflect upward. But the maximum is +1, the minimum is -3. So I'm starting from here. So let me put a dot here. From here, where is the next dot going to be? It's going to be here where we are going to have 90,1. So it has to be somewhere here. Then the next dot is going to be the dot where we are going to have 180,0, which is somewhere here, right? Then the fourth one is going to be the dot where we are going to have this 270, -3, which is going to be somewhere here. Then the last dot is going to end here where we are going to have 360, -1. Since we started from here, so we need to end in the same vertical shift. Let me just put it somewhere here. So that is where we are ending. So graphing this one, we are going to have something like this. It is going to end here. So this graph, we can say it is y, which is going to be equal to 2 sine x minus 1. So this is how you're supposed to graph this one. So before we look at trigonometric equation, let's try to look at the quadrants. So in the first quadrant, all trigonometric ratios, they are positive. In the second quadrant, only sign is positive. So only sign is positive, cos is negative, meaning to say tan is also negative. In the third quadrant, one thing that you need to understand here is that only tan is positive and the rest they are negative. So meaning sine is negative as well as cos is negative. In the fourth quadrant, only cos is positive, meaning to say the rest are going to be negative. Now, you and I know to say that we also have these other trigonometric identities, like we have secant, we also have cosecant, we also have cotangent. So if we say sine is positive in the second quadrant, meaning to say cosecant is going to be negative in the second quadrant. So therefore, this one is going to be negative. Let me say cosecant is going to be negative, since it's the inverse, isn't it? The opposite of cos is secant. Since cos is negative in the second quadrant, secant is going to be positive. Cotangent is the opposite of tan. Tan is negative, meaning to say cotangent is going to be positive. So just follow the same procedure and you're going to see that for this one, since tan is positive, cotangent is going to be negative, and so on. So this is how you're supposed to know this. Now, apart from this one here, there are angles that you need to know. This is 0 degrees, this is 90, this is 180, this is 270, and this is 360. Apart from that one, you need also to know special triangles. These special triangles, they are very, very important to know. So let's say this is 30 and this is 60. This one is going to be 2, this one is going to be 1, and this one is going to be root of 3. Then second special triangle is going to look something like this. This is 90, this is 45, and again this is going to be 45. So here you're going to have root of 2, this is going to be 1, and this one is going to be 1. So for these angles and these two special triangles, they are very, very important when it comes to solving trigonometric equations. So let's start with sine. I always tell you that when it comes to sine and cosine, treat sine as y and treat cosine as x. So meaning to say this is the x-axis and this is the y-axis, isn't it, when you consider it as the Cartesian plane. And you know to say that when it comes to the coordinates x, y, in the y-axis, x is 0, then the value of y you're going to have. In the x-axis, you're going to have the value of x, but the value of y is going to be 0. So what does it mean? When you try to punch on the calculator, you say sine 90. What are you going to get? You're going to get 1. So this one is very, very, very important. So meaning to say, if you're working out trigonometric equations, and then you find that you have, let's say, sine x, which is equal to 1. You want to find the value of x, which is theta, you're going to make this one as the inverse, isn't it? So this is going to be the value of x. What is the inverse of 1? The inverse of 1 is going to be 90 degrees. So that is what I mean when I say take sine as y and take cos as x, because if you say cos 90, definitely here you're going to get 0. But when you say sine 90, you're getting something which is 1. So in terms of the coordinates, if you say cos comma sine, it is same as 0 comma 1 when it comes to 90 degrees, isn't it? This makes sense. But what are we going to do? Let's just do this. Let's also say you're finding sine 0 and also cos 0. What are you going to have? For cos 0, since we're considering this one as y, definitely it is going to be 0 in the x-axis. But in the x-axis, we're considering cos, isn't it? So here we're going to have something, so we're going to get 1. So cos 0 is 1. So meaning to say, when you're answering trigonometric equations and then you have something like cos x is equal to 0, then you're finding the value of x. What is going to be the answer? Cos 0. Let me say cos 1, not cos 0. If you are answering this one here, what is going to be the answer? Actually, it's just going to be 0 degrees, isn't it? That is one thing that you need to know. But not only 0 degrees, you're going to also to find another answer, which is going to be similar. So I'm going to explain. Don't worry about that one. So the first one, we are saying sine 0 is equal to 0, cos 0 degrees is equal to 1, then cos 90 is equal to 0, but sine 90 is equal to 1, isn't it? Now let's say, for example, we move to 180. You and I will know to say that this is the positive side of x and this is the positive side of, this is the negative side of x, this is the positive side of y, and this is the negative side of y. So whatever values that we're going to get for sine here, it has to be positive. That's the reason why we're getting positive 1 here. So when it comes to this one, when you punch on the calculator, you say sine 270, you're going to get negative 1 because it's a negative side of y. Let's come to this one. Let's say you punch on the calculator cos 180. What are you going to get? You're going to get negative 1. But when you say sine 180, definitely here you're going to get 0 because this is x-axis. So these things you need to know them. So meaning to say, if you're solving cos x, which is equal to negative 1, they ask you to find theta. You make x the subject of the formula, which is cos inverse, then negative 1. So definitely what is going to be the value of x? It's going to be 180. You know to say that 180 gives you what? Negative 1 degrees. Negative 1, isn't it? So x is going to be equal to 180 degrees. So that's the idea. So apart from that one, let's move on to 270. So let's say we do this. cos 270. What is going to be the answer? Since 270 is in the y-axis, which is negative y-axis, definitely this one is going to be 0. What about sine? Since this is, we're treating sine as y, so we're going to get negative 1 because it is in the negative y-axis. So even when you punch on the calculator, you're going to get the same thing. So if you're solving sine x is equal to negative 1, then you're finding x. If you make sine the inverse and then negative 1, what is going to be the value of x? Definitely it is going to be 270. So I want you to get this idea, because we'll be using the same idea here that we have. Right? And that one, just use this one. Right, it's fine. So apart from that one, the last one, let's say we have cos 360. So 360 is same as 0 here, so we're going to get 1 because it is cos. But what about sine? This is x-axis, isn't it? So sine 360, definitely we are going to get 0. So meaning to say, if you're finding sine x, which is equal to, let's say 0, okay, then you make sine the subject of the formula like this. So this means that here you can have two values, because 180, it was giving us the same value, which is 0, isn't it? We are getting 0 here. Even for 360, we are getting the same value, which is 360. So for this one, we can have two values. Number 1, we can get 180. Number 2, we can get 360, because these two values, they give us what? 0. So this is how you're supposed to answer these questions. Now, let's also try to talk about the special triangles. These special triangles also, they are going to help us to understand also how you should deal with these trigonometric equations. Okay. So let's start with when you have been taught to find sine 30. You and I will know to say that sine 30 is equal to half. So meaning to say, when you're solving, you have sine x, which is equal to half. You can easily find the value of x, isn't it? You can just say sine inverse, which is going to give you half. So x is going to be equal to 30. Don't even bother yourself, isn't it? But you know to say that cos, let me start with sine. You know to say that sine interior is equal to sine exterior. What it means here is that 30 is the interior angle. So if I try to extend this line here, 30 is inside the triangle, isn't it? Which is the interior angle. So sine interior is equal to sine exterior. So this means that if I have sine 30 here, this one is going to be equal to sine exterior. Now you and I know that the straight line here adds up to 180. So what angle is this one? When I do the computation, I'm going to get 150. So meaning sine 30 is going to be equal to sine 50. So even when you punch on the calculator sine 30, it is going to give you half. Still, when you punch on the calculator sine 50, it is going to give you half. So they are equal to each other. So that is what it means. Alright? So we're going to use the same idea. So meaning to say, if you are answering this question where you have been taught to find the value of x, you can have two values, because you know to say that sine interior is equal to sine exterior. You can have x being equal to 30, or you can have x being equal to 150 degrees. So this is what it means. That one is very important. You're not supposed to forget that one, because we're going to use the same idea here. Let's use this one. Right, so that it is. So apart from that one, let's also try to look at, if you have been taught to find, let's say, sine 60. You and I will know to say that sine is equal to opposite of hypotenuse. So 60, the opposite is root of 3. Hypotenuse is 2. So meaning to say that if you have sine x being equal to root of 3 divided by 2, if you want to find x, if you make sine as the inverse, root of 3 divided by 2, one thing that you need to remember here, you need to remember a special triangle, and then you apply it. You know to say that sine is opposite of hypotenuse. So once you draw this one here, you're going to see which angle between 30 and 60 is having the opposite of root of 3. So as you can see, it is 60, meaning to say here you're going to have what? 60. Now remember what I was saying. I was saying that sine interior is equal to sine exterior, isn't it? That is very, very important to put in mind. Meaning to say, sine 60 is going to be equal to, sine 60 is the interior angle because it is inside the triangle, isn't it? It is going to be equal to sine exterior. So if I extend a line here, this is 180. So meaning, what angle is this one? It is 120. Meaning to say, sine 60 is equal to sine 120. That is one thing that you need to know. So if you punch on the calculator, you're going to get, or if we use this triangle here, we're going to get root of 3 divided by 2. Even this one here is going to give us root of 3 divided by 2. So they are equal to each other. That is one thing that you need to understand and know. Alright, so I think that one is enough for us to answer ideas that we have talked about. So let's say, for example, if we have been taught to find 2 cos squared x, then minus sine x minus 1 is equal to 0. How can you go about this one here? So solve the equation. So when you're solving the equation, this one here is in the format of a quadratic equation. That is one thing that you need to know. So you need to make sure that the variable here that you are finding is the same. So here we have cos and sine. So the only ratio which is in the smallest expression, it is sine. So we can convert this one here into sine. Since we know that sine squared x plus cos squared x is equal to 1, so we can take this one here to the other side. So therefore, cos squared x is going to be equal to 1 minus sine squared x. So we can just put this one here on this part. So we have a 2, which is this one, then open bracket 1 minus sine squared x, then is equal to 0. So this is what we have. Then one thing which I forgot to mention, I was talking about sine interior, which is equal to sine exterior. Let's also talk about cos interior and cos exterior. So cos interior is equal to negative cos exterior. So cos interior is equal to negative cos exterior. So even for tan interior is equal to negative tan exterior. That is one thing that you need to know. So for example, you and I will know to say that cos 60 is equal to 1 over 2. But if you find the exterior angle of cos, it's going to be 120, isn't it? So meaning this 120 is not going to give you a positive value as 1 over 2. Rather, it is going to give you negative 1 over 2. This is what it means. You can also try to use a calculator to confirm that one. Even for tan, if you say tan 45, we know to say that it is 1, isn't it? Which is positive 1. But if you find the exterior angle, which is going to be 135, 135 is not going to give you positive 1, rather it is going to give you negative 1. So that's the meaning. So you need to know that also. Alright, so let's continue. If I multiply, I'm going to have this. So here I'm not supposed to have a 2, but x. So these are like terms, so I can do the assumption. Then I'm going to have this. Let me just do this. That is 1. Then is equal to 0. So from there, I can just try to multiply throughout by negative 1, and then you see what I'm going to have. What I want to do here, I want to eliminate a negative. Okay? I want to eliminate a negative. So if I multiply, I'm going to get 2 sine squared x, and then here I'm going to get positive sine x, then negative 1, which is going to be equal to 0. So in terms of the product, sum and factors, what am I going to have? Here I'm going to get negative 2, which is negative 2 sine. And then here, what am I going to have? Well, let me just remove sine. Just okay. Then the sum here is going to be 1. So in terms of the factors, what am I going to have? I'm going to have positive 2 and negative 2. So let's do the assumption here. We have positive 2 sine x, then minus sine x minus 1 is equal to 0. But there is also the other way that you can use if you are having challenges in terms of dealing with sine. That one you can just say let y equal to sine x. So meaning to say that where we are having sine x, that is where we are going to put y. So therefore, what are we going to have if we put y? 2y squared plus y, then minus 1 is equal to 0. Then you solve for the value of y. Then after finding the value of y, you insert it here. So I'll solve first this one, and also I'm going to solve this one here. Just the same thing. So let me just group these into 2. if I group this into 2 and then find what is common. So what is common here is 2 sine x, and then inside here I'm going to remain with sine x and then plus 1. For this one, what is common is -1. Then what is going to remain is sine x plus 1, then is equal to 0. So we need to say that this one and this one, they are the same. So we have sine x plus 1 is equal to 0. And the next one is going to be 2 sine x minus 1, which is going to be equal to 0. Alright, so that is what we have. So if I get this one to the other side, what am I going to have? So sine x is going to be equal to -1. And x is going to be equal to sine inverse -1. So if you remember very well, which angle gives you -1? When you use those quadrants, this is 90. For 90, it gives you +1. For 270, it gives you what? -1. So that is very, very important to remember. Okay, so that is what we have. So meaning, what is going to be the answer? The value of x is going to be equal to 270. Okay, so for this 270, you can't say there is an exterior angle, because this 270, we are using the idea of the quadrants, unless you have the angle like 45, because this 45 is part of those special triangles. Apart from 45, when you have 30, apart from 30, when you have 60, those are part of special triangle. That is when you can use now the idea of interior and exterior. But otherwise, for this one, you're supposed to have a single value as 270 like that. What about this one? This one, if I take this one to the other side, it's going to be positive. So I'm going to have 2 sine x, which is going to be equal to 1. Then I divide by 2. Then this one is going to give me sine x is equal to half. And x is going to be equal to sine inverse half. So half is part of now those special triangles. So here now you can use the idea of interior and exterior, because it is part of those special triangles. So our x is going to be equal to, which value can give us this one here? The first one can be 30. Apart from that one, the next one can be what? Can be 150. Where are these coming from? You know to say that this 30 is a special angle and it is the interior. And what I've said about sine is that sine interior is equal to sine exterior. So meaning to say, if we have interior angle as 30, the exterior angle is going to be 150 if we draw a straight line. And we know to say a straight line has up to 180. So those are equal to each other. But when it comes to sine and when it comes to cos and tan, it's just the opposite. Cos interior is equal to negative cos exterior. Tan interior is equal to negative tan exterior. So those things you need to know them. So these are the values that you're supposed to find. So you need to write them in order, starting from the smallest one. So the smallest one is 30. Then the second one is going to be 150. Then the last one is going to be x being equal to 270. So this is how you're supposed to find these values. And it is very, very important to find all the values like the way I found these. Let me give you another example. Now, that question which I'm from answering, I was just answering for the sake of showing you how you're supposed to answer. But what is important when you're answering is to follow what we call the range. Let's say the range is from 0 degrees, which is less than or equal to x, less than or equal to 2 pi. The range is going to tell you, 1, the units of the angle in which you're going to give them. Apart from that one, how you're going to write your answers in terms of the range. So this is from 0 to 2 pi. 2 pi is 360. So meaning that all the answers that you're going to find, or that we're going to find, should be in the range of 0 to 360. And these are positives. Do not include the negatives. That is very, very important to understand. Alright, so let's start with this one here. Let's say we have 2, then sine x, let me say sine squared x, then let's say plus 3 sine, then let's say x plus 1 is equal to 0. So as you can see, this one is just very simple, because we know to say that we have sine and sine, so it's just a walkover. So for that one, which I told you that I am going to show you the other way, you can just try also to use the other way around by finding the value of y and then you reverse it like that. Otherwise, also I'm going to show you using this one. So if we say let y being equal to x, let me say y being equal to sine x, meaning to say here we are going to have 2y squared plus y plus 1, which is going to be equal to 0. So here I can find the product, which is going to be 2, the sum, which is going to be 1, the factors, which are going to be 2 and Are we going to have any factor here? Let me just say this one is 3. Sorry for that. So the sum is 3. So meaning the factors we are going to have 2, 3. So this makes sense, isn't it? So from here, I'm going to do the assumption. This is what I have. So what is common here is 2y. Then y here plus 1. Then what is common here is 1. Y plus 1. Then is equal to 0. So solving for this one here, y is going to be equal to -1. So meaning to say y is equal to -1, I'm going to put it here. Now let me just find this one also. We have 2 plus 1, which is equal to 0. So y is going to be equal to -1 over 2. These are the values which I have. So in an exam, when you find it like this, you are not done. You need to take these values, then you insert them here because you're finding the value of x. So I'm going to start with the first one. So we have sine x, which is equal to the first one, -1. And sine x is equal to the second one is -2. Here, what do we have? X, then sine inverse, then open bracket -1. Here I'm having -1. What value am I going to get? It is going to be 270. So I've explained where you're supposed to get these values. You consider sine as y. Now you know to say that 270 is in the negative y-axis. So it is going to give you -1 when you say sine 270 on the calculator. So this is the value that we have. Here we are using the idea of quadrants. What about this one, -1 over 2? Here we are using the idea of special triangles. X is going to be equal to sine inverse -1 over 2. So meaning to say, if we are saying sine interior is equal to sine exterior, that is very important to understand. So meaning to say, what we are going to have here, we know to say the angle which gives sine as half is 30 and it is having negative. So the first thing you are going to have -30. Right? Apart from -30, what are you going to have? Since sine interior is equal to sine exterior, you need also to have -150. Now, according to the range, we are starting from +0 up to 360. So meaning to say, these, they are not supposed to be part of the answers as -30 and the -50. Just that one is clear. So meaning to say, what are we going to have? We're just going to have this one as our value. So you're not supposed even to show this one. I was just showing you. So for this one, you can just end here unless otherwise.